Hello guys, welcome back to STR8CHEM. In this video, we're going to look at some basic problem solving in percentage by mass. Percentage by mass is defined as the percentage of the mass of solute per mass of solution. In this case, we're going to focus on the solute and solution. Alternatively, you can write the definition as follows. You can write percentage by mass over is equals to mass of solute over mass of solution times 100. That is acceptable as well. Let's look at the example given. The example over here says that what is the concentration by mass of the solution formed when we have 7.3 grams of salt is dissolved in 33 grams of water. Okay, so we have very important information given to you here. You have salt and water. So the solutions will look like this. This is the mass of your solute, which is the salt, and then the mass of your solution. Remember, this is your solute, and that is your solvent. So to get the solution, you have to add them up together. This is solute, and this is your solvent. Remember what we talked about solution concept before. Solution is equals to solute plus solvent. In this case, since we're talking about the mass, so we're going to have mass of solution is equals to the mass of solute plus mass of solvent. So that is the mass of solute, and this is the mass of solvent. That's why we have 7.3 plus 33 grams down there. Okay, and the answer is 18.11%. Now, let's have a look at one example. A 0.80 mole decimeter cubic solution of sulfuric acid has a density of 1.10 gram per centimeter cubic at room temperature. What is the concentration of this solution in weight percent? And the relative molecular mass of sulfuric acid given to us, 98. To do this, we're going to start with step 1, which is you have to consider first 1 decimeter cubic of H2SO4. Why do we need to consider 1 decimeter cubic? Because you are given this information. You are given with this information over here, 0.80 mole per decimeter cubic. So from this piece of information, we can deduce that in every 1 liter, 1 decimeter cubic of H2SO4, we will have 0.80 mole of your H2SO4. Okay, so we will have 0.80 mole of H2SO4. That's why we need to consider 1 decimeter cubic. Okay, it's kind of like an assumption, okay, but we are assuming from what we are given in the question. The question says you have 0.80 mole per decimeter cubic, and the question does not give you a specific volume. So that's why we can do this consideration right here. When you have 1 decimeter cubic, that means you're going to have 0.80 mole of H2SO4. Okay? And then from there, we would be able to find the mass of your solute. Okay? Remember just now when you want to talk about the percentage by mass, we need to have the mass of your solute over the mass of your solution. That's why in here, step 1 is necessary because we need to find out the mass of your solute, which is H2SO4. We have got the number of mole already, and we can use the relative molecular mass of H2SO4. This one is also it will have the same number for the molar mass, just that for molar mass you're going to have units, gram per mole. We take 0.80 mole times 98 gram per mole, and we will have the mass of solute 78.4 grams right here. Moving on to step 2, what we need to do is we need to find the mass of solution. In step 1, we have worked out the mass of your solute, and in step 2, we're going to find the mass of your solution from the density. The density is given to you. Okay, we have 1.10 gram per centimeter cubic. And we need to know that the density of solution is defined as mass over volume. Mass of solution over volume of solution. Okay, so if we can find the volume of the solution, we should be able to work out the mass over here. Okay, so since we have considered 1 decimeter cubic as the volume that we want to use to work with the equations over here, then we can put the volume of the solution as 1,000 centimeter cubic. 1,000 centimeter cubic is the same as 1 decimeter cubic. Remember that. Okay, from where did I get this one? It's from the first consideration that we have made in step number 1. So when I take that into consideration, I should be able to solve this and get the mass of solution, which is 1100 grams. In step 1, we have got the mass of solute. In step 2, we have the mass of your solution. Okay, this is the density of the solution. Okay, you have the solution here. You have the word solution, remember? So the consideration that we have got here is the volume for solution. So that's why I can take this and I can put it in here as well, because the information for density over here refers to the solution. Okay, and in step 3, what we need to do is percentage by mass. You're just going to plug in every information that you have worked out in step 1 and step 2. 78.4 grams, that is the mass of solute, over 1100 grams, that is the mass of your solution, times 100, and therefore the percentage by mass for this question is 7.13%.